Hello everyone, welcome back to my channel. Let's learn today parametric. So let's get started. So today the topic is parametric versus non-parametric test. The parametric test makes certain assumptions. This is very important for us because in parametric data there are certain assumptions. What are those? The data is drawn from a population. This is one of the most important assumptions for parametric test, and then it should be from a normal distribution. Variable in the populations are measured based on interval scale. This is another, we know that data is of four types, and out of that, if data is on interval scale, then parametric tests are being applied. What happens in parametric test normally? In parametric test, mean is equal to mode and it is equal to median as well. And more important thing, there is no skewness. Means to say, most of the time, it is symmetrical in nature. When data is symmetrical in nature, that it is known, it is parametric. Here you can see the shape of distribution. It is almost normal, right? Because we can say in the center, mean, median, mode, all are lying here. So this is what we can say in the single case here. So the mean, median, and mode are normally coming on in the center. So this is the assumption of parametric test. Or the data shape can be like this, where you can have almost the variance is almost equal. Although these are two different series, different symmetrical distributions, but their variance seems to be equal. So these, under these conditions, they are known to be parametric. Let me give you some example from the real world. Let's see, normally what is the blood sugar of a person? Can you tell me? Blood sugar level? It should be 70 to 100 normally. Okay. What is the BP range? Blood pressure. It is normally 120 to 80. So these are some known as parameters. And what is the temperature level of a body? Can you tell me? Yes, it is 98.6 degrees centigrade, which is considered to be a normal data. So when we have data and when we have these kind of values, because these are the universal phenomena and taken from the population at large. So we can say these are known as parameters. So when the data is calculated in this way for various people, we want to take the temperature level, we want to for their blood pressure level, and we want to have their blood sugar level, or one more measure which is HB1AC, that normally 5.5 and above, which keeps on changing. So under these conditions, these are considered as normal conditions, and that kind of data when collected is known as the parametric data. But always the things are not like that. There are certain conditions when these assumptions are not met. When there are so few assumptions are met and there is no distribution, that are known as non-parametric test. That is known as non-parametric test. They are less powerful, but there are certain assumptions under which condition these need to be calculated. For example, when COVID-19 episode came into the picture, at that time, a lot of vaccines were manufactured by the companies and the people were reluctant to test themselves for these new vaccines. What happened under these conditions? Because they are very critical, the patient may die or casualty may arise. So normally when we conduct these kind of medical tests, we have very few sample. On that small sample size, we need to run the efficacy of the medicines, whether they are working well or not. So under these conditions, we cannot collect the data from the large population, and it is from the small population. Under those conditions, they cannot be distribution. They are known as distribution free, and we are not aware about the data. So, and we have very less information where we can take some decisions. So these kind of the situation under where non-parametric test, we can see this is distribution is almost different. Another example, one more example, but normally you can say here the position is not normal. So under these conditions, we have to use non-parametric. So let's recall what I told you previously. When the sample size is very small and instead of mean, we must use the median, and where the data is not a normal distribution, at ordinal scale or we can rank them, and in certain condition where outliers cannot be removed. And when the measurement scale is nominal or ordinal, under these conditions, we have to use non-parametric test. Let's see on this table. This is parametric test, and here we have non-parametric test. What are the assumptions? There are certain assumptions into this, but advantage of non-parametric test that there are no assumptions made. Then what is the central tendency? I just told you that here we are aware mean values are being considered, and here median value is given more preference. Correlation, if you have to calculate correlation, it is Pearson, and here it is Pearson correlation. Probabilities, and what kind of distribution is there? It is normal and arbitrary, means there is no pattern is known. Population knowledge is very much essential or required, and here it is not required. Then why it is used for? It is used for the interval data, and it is used for finding nominal data. Then what are the application? It is used to the variables only. There is application, it has its application into variables only, whereas it can be applied to variables as well as attribute. Under certain conditions, parametric tests are also become important. We cannot ignore them. And what are the various tests? Jet test and t-test are the two important prominent tests in the parametric test, and ANOVA is also taken. And here Mann-Whitney and Kruskal-Wallis test is being used. Let's see in detail what are the various tests. In non-parametric test, what it does? It compares one median to a specified value. But if we have parametric test, what are the tests available? Either we use jet test or one sample t-test. And when we have two dependent paired medians, similar test in parametric is used as paired sample t-test, or which is also dependent. Where the Mann-Whitney test is used, it compares two independent medians, and here we have two independent sample t-tests. Where Kruskal-Wallis test is used, when we have three or more medians, but that is related to one variable, and here we use one-way ANOVA. Then Friedman test, three or more median values, and variables are two. Here we use two-way ANOVA. And then there is one more thing, chi-square test of independence. It tests two categorical variables for independence and lack of association, and there is no such condition in case of parametric test. So this is a small comparison, very essential for the basic things that we should know. What is the difference between parametric and non-parametric tests? Please like, share, and leave a comment if you like this video. Thank you.